Hello students, this is a video on the quant topic tests available at Bodhee Prep. These tests are designed for you to understand your preparedness for a topic. So once you've done the basic concepts of the topic, you take the test to understand whether they are ready or not. With every test, there is a video. The video gives you the solution plus a brief analysis of the level of difficulty and the amount of time that should be spent on the test in the exam format. There are more than 200 topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. Make sure you download the app and make the most of make the most use of these tests. This video is about the topic integral solutions and inequalities. This is the first test in the topic, and in terms of level of difficulty, it was probably moderate to difficult sort of a test where you would expect around 6 odd questions to get you a 95 plus percentile for sure. The attempt time for these questions would be about 22 minutes. That is going through all the questions and getting our 5 to 6 questions correct. If we look at the questions, the first one says the number of solutions of the equation 2x plus y is equal to 40, where both x and y are positive integers and x is less than equal to y. So let us start with the highest value of y that is possible. That will be 40, in which case x will be 0. They are both positive, so this will not be counted. We go on to the next value of y. From this point, the value of y will decrease with the coefficient of x, and the value of x will increase with the coefficient of y. And therefore 38, this will become 1, 36, 2, and so on. Now, there will be a point where x and y will be equal. The best possible point where x and y are equal will be x plus y, or x plus x is equal to 40, which means 3x is 40 or x is equal to approximately 13. So when we put x as 13 here, 2 13s are 26, 26 minus 40 is 14. Beyond this point, x will be 14, y will be 12. And from here on, x will not be, or x will become greater than y. So we are looking at solutions in this range. Y was 2 into 19, 2 into 18, and then goes down to 2 into 7. Therefore, number of solutions for y are from 7 to 19, which is 19 minus 7 plus 1, which is 13. Or we can look at x. X goes from 1 to 13. Therefore, the number of solutions possible are 13. I think because of the numbers, easy to moderate question, 2 minutes should be good enough to answer this question. What values of x satisfy x raised to power 2 by 3 plus x raised to power 1 by 3 minus 2 less than equal to 0? Now this can be written as x 1 by 3 squared plus x raised to power 1 by 3 minus 2 is less than equal to 0. Replace x raised to power 1 by 3 by y. This becomes a quadratic in y. Y square plus y minus 2 is less than equal to 0. We are looking at two numbers which add up to 1 and have a product of minus 2. So y plus 2 into y minus 1 is less than equal to 0, which gives us y is equal to minus 2 or y is equal to 1. Oh, sorry, less than equal to 0. It's an inequality. The critical points will be minus 2 and 1. Minus 2, 1. Positive, negative, positive. We are looking at the negative values. Therefore, minus 2 less than equal to y less than equal to 1. But minus 2 is nothing but x raised to power 1 by 3. If we take the cube of the entire thing, minus 2 cube is minus 8. X 1 by 3 cube is x. 1 cube is 1, and therefore x has to lie between minus 8 and 1. It's an easy question, standard format question. So I'm saying easy, within about 90 seconds, we should be able to solve. Another way of doing this question in exam is simply put the values. See, if I put x here 0, 0 raised to power anything is 0, 0 raised to power anything is 0, minus 2. So x is equal to 0 will satisfy this equation. Now, in this range, x is equal to 0 is not present. In this range, x is equal to 0 is not present. Now, if I take x as 8, 8 raised to power 2 by 3 will be 4, 8 raised to power 1 by 3 will be 2. 4 plus 2, 6, minus 2 is not less than 0. So, this cannot be the answer. Whatever remains is my answer. That is also a legitimate way of doing this question. If m and n are integers such that m minus n whole square is equal to 4mn upon m plus n minus 1, then how many pairs of m comma n are possible? If we write this as m minus n whole square into m plus n minus 1 is equal to 4mn, and then we expand it and say m square plus n square minus 2mn into m plus n minus 1 is equal to 4mn. This becomes m cube plus n square m minus 2m square n plus m square n plus n cube minus 2m n square minus m square minus n square plus 2mn is equal to 4mn. This can be written as m cube plus n cube. These two terms have been taken care of. N square m minus 2m square n square m will give us minus n square m. This and this is gone. This will give us minus m square n. From here we get minus of m square plus n square plus 2mn. On the right hand side, this will become minus 4mn. Therefore, plus 2mn is equal to 0. M cube plus n cube can be written as m plus n into m square minus mn plus n square. This becomes minus of mn into m plus n. This becomes minus m plus n whole squared. From this, we can take m plus n common. We'll be left with m square minus mn plus n square minus mn, and from here minus m minus n, minus m plus minus of m plus n common, so this is 0, which means m plus n into m square plus n square minus 2mn minus m plus n, again we can write this in bracket, is equal to 0, which means m plus n into this is m, this will be m minus n whole square, m minus n whole square minus m plus n is 0. Now for this to be 0, the product to be 0, one of the solutions always will be that m plus n is 0 or m is equal to minus n. So if, since m and n are integers, if we put the value of m such that m and n are negative of each other, this equation will always be true. For example, if we put m as 1 and n as minus 1, this will become 1 minus minus 1, 2 square 4. 4 into 1 minus 1 upon minus 1 will again give us 4. Similarly, m is 2, n is minus 2 will still give us the equation to be true, and therefore infinite solutions are possible. I will call this question a moderate level of difficulty question, because even if we start putting the values at one point, we might crack the fact that negative values will work with this question. But I think the attempt time will go up to 2.5 to 3 minutes also. If a square minus 3b square is 1001, then the number of integer solutions for the given equation is a square minus 3b square is equal to 1001. Now, if this number is a multiple of 3, if we look at 1001 divided by 3, that leaves a remainder of 2. 1 plus 1 is 2. Also, if we look at a square, for example, 1, 2, 4, 1, 4, 9, 16, 2, 3, 4, 5, 6. If we divide squares by 3, we realize that the remainders are either 1 or 0. For any square, remainder divided by 3 is either 1 or 0. 16 by 3 is 1. So if we look at this entire thing and we divide the entire thing by 3, the remainder here will be 1, the remainder here will be 0, the remainder here will be 2, which is not possible. If I divide the entire thing by 3, then a square minus b square should give me equal to 1001 by 3. Here the remainder is 1, here the remainder is 0, here the remainder is 2, which is not possible. And therefore integral values will not be there. So what is the number of integer solutions of the given equation? There are 0 solutions possible for this given equation. Since the 3 was there and we are just checking for remainders, I am saying probably a moderate, easy to moderate level of difficulty. Solving time should not be more than a minute and a half to 2 minutes. The number of solutions of the equation 3p plus 4q is 70. P and q are positive integers. P is greater than q. Okay. Uh, 70. If you look at the multiple of 4 less than 70, 70 by removing 3, 67, 64. 64 is a multiple. Or if you look at a multiple of 3 by removing 4. So, because we want a higher value of q, 70 minus 4 is 66, which is divisible by 3. So, if we put p as 22, 3 2s are 66 plus 1. This will give us 70. 66 plus 4 is 70. Number of solutions of the equation P and Q are positive integers. P is greater than Q. Now P will reduce with the coefficient of Q and Q will increase with the coefficient of P. So the next solution will be 18 and 4. 3 18s are 54, 4 4s are 16. 14 and 7, 4 3s are 30, 14 3s are 42 plus 28, 10 and 10. This is where they become equal. 30 and 14. Beyond this, P will be less than Q. And therefore, the number of positive integral solutions where P is greater than Q will be these three. Again, not a very difficult question because of the numbers that are not very difficult. Getting the first point might be a bit of a challenge, but about 2 minutes to solve, moderate level of difficulty. A and B are integers. How many ordered pairs AB satisfy the equation A square plus AB plus B square is 1? They are integers. They are not necessarily positive. A square plus AB plus B square. We can write this as b square plus ab plus a square minus 1. Now this can be written as b square plus 2 into a by 2b. What I'm doing, I'm trying to complete the square in b. Since we have a by 2 here, we write the square of a by 2 and then subtract the square of a by 2 plus a square minus 1 is equal to 0. This becomes b plus a by 2 whole squared. What we are left with here is 1 comes on the right hand side. This becomes a square. A square minus a square will be 3 a square minus 3a square by 4, which can be written as b plus a by 2 whole square. 4 minus 3a square by 4. Taking the root, we have b plus a by 2 is equal to plus minus root of b minus 3a square by 4. Or b is equal to plus minus, this will be 2 under root. Plus minus root of 4 minus 3a square minus a by 2, so minus a upon 2. Now clearly the root has to be positive or 0 at max, and therefore if 4 minus 3a square has to be greater than equal to 0, 3a square has to be less than equal to 4, or a square has to be less than equal to 4 by 3. The values that a can take are, cannot be 2 or minus 2, a can be minus 1, a can be 0, a can be 1. If a is minus 1, in that case b will be, or we simply put the values here. If a is minus 1, we have 1 minus b plus b square is equal to 1, and therefore b square minus b is equal to 0, which means b into b minus 1 is 0. So when a is 1, b could be 0 or 1. When a is 0, we have 0 plus b square is equal to 1. So b could be plus 1 or minus 1. When a is 1, a square plus ab plus b square is equal to 1. A is 1. So 1 plus AB plus 1 plus B plus B square is equal to 1, which means B square plus B is equal to 0, which means B into B minus 1, B plus 1 is equal to 0. So either B is equal to 0 or B is equal to 1. Hence you get 6 solutions: minus a 0, minus 1, 1, 0, 1, 0, minus 1, 1, 0, 1, 1, 1. Therefore, 6 ordered pairs are possible. That's a moderate level of difficulty question. expressing the sum as a quadratic in B is the only challenge. Beyond that, the values are simple, and therefore about 2.5 to 3 minutes to solve. If fx is equal to x square, gx is equal to 2 raised to power x for how many non-negative? Non-negative matlab x could be 0 or positive. Let us look at x is equal to 0. Or let us look at values of x, fx and gx. When x is 0, fx will be 1, x 0 square, gx will be 1. When x is 1, fx will be 1, x square, gx will be 2. When x is 2, fx will be 2 square, 4. Gx will be 2 raised to power 2, 4. When x is 3, 3 square, 9, 2 cube, 8. When x is 4, 4 square, 16, 2 raised to power 4, 16. When x is 5, 25 and 32. X is 6, 36 and 64. Beyond this point, fx will always be less than gx. Here fx and gx are equal. Here fx is greater than gx. Here they are equal. Fx is less than, so there are 3 points that we get where fx will be greater than equal to gx for non-negative integers x. Again, just putting values and checking is all we had to do. 1.5 minutes should be good enough for this question. X is root of minus 15 minus 11, y is root of 27 minus 23, z is 2 into root of 6 minus 5. This can be written as 6 into 4, 24 minus 5 into 2 base. Basically 2 is equal to root of 4. So we multiply, so 24 minus 20. As you can see, the difference between these numbers in each case is 4. So I rationalize this or multiply and divide by the conjugate. So this can be written as root of 15 minus root of 11 into root of 15 plus root of 11 by root of 15 plus root of 11. And therefore x will be nothing but 15 minus 11 by root of 15 plus root of 11. Therefore x can be written as 4 upon root of 15 plus root of 11. By a very similar logic, y can be written as 4 upon root of 27 plus root of 23, multiplying and dividing by root of 27 plus root of 23. And z will be 4 upon root of 24 plus root of 20. Now we deal with the denominators. Suppose the denominators are a, b, c in the 3 cases. A is root of 15 plus root of 11. Take the square of a. 15, or rather we don't need to do that. If we look at the denominators, we can see that root of 27 is greater than root of 24 is greater than root of 15, root of 11, root of 23. Root of 23 is greater than root of 20 is greater than root of 11, and therefore the sum root of 27 plus root of 23 will be greater than root of 24 plus root of 20 will be greater than root of 15 plus root of 11. That means B is greater than C is greater than A. Now if the denominator is larger, the fraction will be smaller, and therefore the largest or the smallest fraction becomes the largest value, and therefore x is greater than z is greater than y becomes my answer. Option D. Denominator large means fraction small. Again, I would call this a difficult, moderate to difficult question, taking 2.5 to 3 minutes for a simple reason that constant sums are easier to deal with than constant differences, and therefore this might take some thinking. How many negative integer solutions exist for x square minus y square is equal to 400? X square minus y square can be written as x plus y into x minus y. Now if we look at 400, 400 is 4 into 100 or 4, it's 16 into 25, which is 2 raised to power 4 into 5 square. So the number of factors here is 5 into 3, which is 15. So these factors will be 1, 2, 4, 5, 8, 10, 1, 2, 3, 4, 5, 6. 16, 20, 1, 2, 3, 4, 5, 6, 7, 8. 16 into 25, 10 into 40, 8 into 50, 5 into 80, 4 into 100, 2 into 200, and 1 into 400. Now, if we look at x plus y as 1 and x minus y as 400, we'll get 2x is equal to 401, which will not give us a integral solution. Because one of the values is odd, one of the values is even. The sum will be odd, and on adding this, we'll get twice of x, which is even. So the sum has to be even. So we can eliminate the cases where one of the number is even, one of the number is odd. So 400 goes away, 5 and 80 goes away, 16 and 25 goes away. One of the number even, one of the number odd. That will not work for me. We will not have a case where both the numbers are odd, because odd into odd cannot give us 400. Now, if we look at x plus y is equal to 2, x minus y is equal to 200. What happens is we get 2x is equal to 202, which gives us x as 101, and y is therefore minus 99. We want negative integers. If we have both the values positive, if the addition value is small, we'll get one positive, one negative. Whereas if we write it as x plus y is 200, x minus y is 2, in that case, you'll get x as 101 and y as 99, both will be positive. And therefore, this case will not be considered. What we need is both the values to be negative. So if we say x plus y is equal to minus 2, x minus y is equal to minus 200, so that the product is 400. In this case, 2x will be minus 202, x will come out to minus 99, minus 101, and x will come out to minus 101. If you put minus 10, y will come out to 99. Again, one is positive, one is negative. So the only possibilities are that x plus y is a higher negative value, x minus, or a lower negative value in that sense, and x minus y is a smaller negative value. So, or a larger negative value. Or in terms of magnitude, x plus y should be larger, x minus y should be smaller, and both should be negative. Here we'll get 2x is minus 202, or x is minus 101, and therefore y is minus 99. Both the terms will be negative. And therefore, we can have the number of cases as 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Where both the terms are positive, one could be a higher positive value, negative value in magnitude, and the difference is a lower magnitude value. Now we look at the last solution, that is 20 and 20. If x plus y is minus 20 and x minus y is minus 20, on adding we simply get 2x is equal to minus 40, which means x is equal to minus 20 and y is equal to 0. So even this solution will not be counted, and therefore we are left with 4 solutions. Option A becomes the answer. I think moderate to difficult level of question. If we know how to count, we will not have to make all the cases and check. That is the case where it will take about 2 minutes to solve. If we have to check for every case every time, this will easily take more than 3 minutes. Find the minimum possible value of y if 9 by 17 is less than equal to x by y is less than equal to 25 by 43, x and y are real numbers. So what I do is, we find the decimal value of 9 by 17. Using the calculator, this is approximately 0.529. This is less than x by y. And again, 25 divided by 43. 25 divided by 43 is 0.581. Now, if we look at common fractions, that is 1 by 2, 1 by 3, 1 by 4, and so on, and their multiples being in this range, obviously 1 by 2 will be either 50 or 1, 2 by 2 will be 1. Multiples of 0.3 will be 0.33, 0.67, 1, this will be 0.25, 0.5, 0.75, not in this range. 0.6, 0.4, 0.6, not in this range. This will be 3 by 6 will be 0.5 and then 0.67, not in this range. If you look at 1 by 7, multiple 4 by 7 of 1 by 7 is 0.5714. This is a value that we remember. So, and that lies between the range of 0.52 and 0.58. So the minimum value that x by y can take is 4 by 7. 4 by 7 is between this range and will be the smallest value that y can take. Hence my answer here becomes 7 because x and y are natural numbers. I would call this question a difficult question unless we know that we can go about this question in this way. It might not be something that strikes very quickly. So if you look at the overall test, as I said, moderate to difficult level, we're looking at about 6 questions. If I have to choose my 6 questions, they would be 1, 2, 4, 5, 7, 9, which definitely doing this one, linear equation, number of solutions to be found out. I have done this question earlier or similar question earlier, therefore would be doing this. This I think was a difficult question. Might not get answers very simply. Here, since we are just dividing by 3, therefore I'm counting this question. Again, linear equation, number of solutions is not very difficult, so attempting this question as well. This I think was a difficult question. The quadratic in B was not something that might strike every time. This putting values and solving, so counting this question. If you know it, you know it. If you don't, it might not be very obvious and therefore not counting this one. I am counting this question because it might take time, but it will give you an answer for sure because the method is straightforward. This question also, if you know it, chances of attempting are higher. Otherwise, a difficult question. And therefore, my 6 questions will be 1, 2, 4, 5, 7, and 9.